All right, good morning, everyone. Today we are going to review everything that we talked about last week for the chi-square tests, and specifically, when do we know to do a chi-square test? And that's what we're going to start with today, is talking about the differences between the three chi-square tests that we learned to do last week, as well as kind of adding this to our repertoire of significance tests in general. We have learned sample means, sample proportions, and how to know when to use each of those tests for one sample or two samples, or are we using a Z or a T, that kind of thing. So we want to zoom in on the chi-square test so that we know exactly when to use these tests in any given problem that asks for significance. So first, let's just look at the goodness of fit test, the one that we did on Tuesday and Wednesday of last week. So let's first just look at how do we find the test statistic. So we know that we have this formula, chi-square is equal to the observed values minus the expected value, quantity squared, over the expected value. And so we want to know, once we find this value, what exactly are we testing for? So we're trying to see, and most often our hypotheses are, our null is to see if we have equality between our observed and our expected values. And then our alternate hypothesis is, are the observed values not equal to the expected? And then some key identifying words in the problem that would help us know when to use the goodness of fit test is really, do they say anything about equality in the problem? Because that's really what we're looking for, equality between the observed and the expected. Do they give percentages for multiple categories? And lastly, it's a table with one row of values, or I should say one row or column of values. And this is really definitive of the goodness of fit test, because every time we have a problem, let's say we have some sort of things going on up here, maybe freshmen versus seniors, or whatever it may be, and we have some values and whatever this may be. It's a table that looks something like this. It only has one row of observed values, and that is the defining feature of a goodness of fit test. If you are given a table that has a row of observed values, one row, and it's asking you for significance, that is going to be the goodness of fit test. So that is a defining feature of this test. You know that you're going to do the goodness of fit test if they give you a table with only one row of values. Then for homogeneity, so how do we find that test statistic? Well, we just do this in the calculator, but let's just go ahead and write down the steps that we do in the calculator, just so that we're all on the same page as to how to find this. I'm going to kind of start up here so I can give myself a little bit of room. So we press second, we go to x to the negative first, which opens up the matrix function. Then we're prompted to enter the number of rows and columns. And then we enter the table values. Only the observed values. So no totals. And then after we do that, we can press Stat, go over to Tests, then the chi-square tests, and then it should give you matrix A, and then just press Calculate. So that'll give you your chi-square test statistic and your p-value as well as your degrees of freedom. The second box here, what are we testing for? So really we're testing for similarity between our categories. So again, that prefix homo means same, so that's why we're looking for similarity. So our null hypothesis is always similar, similar hair length versus height or something like that, or gender, who knows, whatever it may be, but it's always the two categories are similar, and then the alternate is whatever your categories are not similar. Some key identifying words in the problem is honestly the word same. And then some other things, you have a two-way table, and here you're looking at two categories rather than just one in the goodness of fit test. So one thing that's very similar between the independence test and the homogeneity test is that we have this two-way frequency table, and that's what's giving us sort of this kind of similar, no, not similar, versus association, not associated, kind of two-way test. So then for when we have independence, again, we find this using our calculator, same as homogeneity. And then our hypotheses, you can write this in multiple ways. For specifically in terms of independence, the null is that whatever your categories are, they are independent of each other. In a way that you're saying that there's no relationship or there's no association going on. And then alternatively, that's why we call it our alternate hypothesis, we have that they are not independent, whatever their categories are, and that there is a relationship. So if they're not independent, then they affect each other, there is a relationship going on, or an association. And then lastly, some key features in the prompt is they might say, is there a relationship between these two things? They might explicitly say association or independence. And then again, we sort of have that two-way table going on. So again, we have two categories. And a lot of times the independence test is usually comparing groups of people sometimes in terms of certain aspects about them. So a lot of times it's your height or your weight or your foot length or your handedness, whether you're left or right-handed, that kind of thing. And then so a lot of times, and not all the time, a lot of the time, whenever you're looking at a table that's men versus women, then that is going to be most times a chi-square test for independence. That is similar to when we see a paired t-test or a matched pair design, how we have twins. That's just an identifying feature. So if you did not have a chance to write this all down, please just go ahead and pause the video so that you can have this in your notes. So a lot of good information here, especially the identifying words. Those can be really helpful, especially between our homogeneity and independence tests. Okay, so let's look at an example where we can learn and use our information on this table to actually figure out what type of tests we need to do. So here we have a geneticist was curious about the relationship between gender and dominant hand. They surveyed a random sample of 500 people. Here is a summary of the responses and the results from a chi-square test. Assume that all conditions for inference have been met at the 0.05 alpha significance level. What is the most appropriate conclusion to draw from this test? So they've already stated that they've done a chi-square test. Even if they didn't state this, I would know that this needs to be a chi-square test based on the way that the information is given to me in terms of a two-way table. So I already know that this either has to be homogeneity or independence based on this two-way table. So now I'm going to go back to the problem and I'm going to see, okay, what information is given to me that might clue me in on whether I'm looking at homogeneity and independence. So I want you to pause the video and think about what information is given and try to sort of figure it out on your own. Okay, so let's take a look at what we have, see if you're right. So here it says we're trying to determine a relationship between gender and dominant hand. Well, if I go back to my table and I see, okay, I remember writing down the word relationship. Where did I write that down? Well, I see that I wrote it here under independence. So that means that I'm doing the chi-square test for independence. So let's go ahead and write our hypotheses for this. So our null hypothesis is going to be that there is independence between gender and dominant hand. And then our alternates, no independence between gender and dominant hand. Okay, so now that's my first step. My second step is to test my conditions. However, they say right here that my conditions for inference have been met. So I am good to go with my second step. So I'm just going to write conditions. We're good to go there. So now I need to calculate my test statistic. So I go back to my handy dandy table and I see, okay, how do I find the test statistic for an independence test? Well, it says that I need to look at my calculator. It's the same as the homogeneity test. So I'm going to follow these steps here. So let's pull out our calculator and let's follow those steps. So we have seconds, x to the negative first, go over to edit, matrix A, enter the number of rows and columns. Let's go ahead and go get that information. So I only want to enter the observed values, so I'm only focusing on these gray rows here. So I have a 3 rows by 2 columns in my table. So 3 rows, 2 columns, and then enter our values. So 207, 220, 207, enter. 227, enter. 21, 27, 12, and 6. Okay, so then it says go to stats, tests, the chi-square test, make sure I have matrix A as observed, and then it'll auto calculate the expected. So let's calculate. And there we have our test statistic, our p-value, and our degrees of freedom. So it said that chi-square was equal to 2.88. Our p-value is equal to 0.237, and our degrees of freedom was 2. So I need my alpha, which was 0.05. So this is definitely greater than alpha. So I'm going to fail to reject my null. And let's just go ahead and write our conclusion. So, because our question is asking about the conclusion, so we say that at the alpha equals 0.05 level, there is independence or no relationship between gender and dominant hand. So that is our final conclusion. All right, so go ahead and complete the classwork and exit ticket for the Monday lesson on Google Classroom. And I'll be on Zoom at 8:20. All right, have a great rest of your day, everyone.